All right, in this video, we're going to talk about the properties of polygons using coordinate geometry. This is section 13.2. Okay, so basically, we'll start off with the Pythagorean Theorem and the distance formula. Okay, but the Pythagorean Theorem and distance formula. And we're going to use the Pythagorean Theorem to derive the distance formula. Okay. Here, our objective is to derive a formula for the distance between AB and, the distance AB, I should say, between 2 points, where A is going to be x1, y1, and B will be x2, y2. And to achieve this, we're going to combine our knowledge about vertical lines, horizontal lines, and the Pythagorean Theorem. If you remember, the Pythagorean Theorem is this: a squared plus b squared is equal to c squared. Okay, and this is in a right triangle. The square of the hypotenuse will be equal to the sum of the squares of the two legs of that right triangle. So in this particular example here, this shows 2 points where P has the ordered pair 3, 2, and Q has the ordered pair 3, -4 on the vertical line PQ, given by the equation x is equal to 3. And I want to determine the distance between P and Q. And pretty much how we arrived at that answer. Okay. Now, I'm going to move this down a bit so that way you can see the answer to part A. And that answer, of course, is going to be 6 units. And we did that by counting the units. So let me go back here. If I can see this. Here's P and here's Q. If you start here and count down 1, 2, 3, 4, 5, 6 places, that distance between P and Q is going to be 6. So just count those units. And then in part B, you have 2 points, S, which is -3, 4 as an ordered pair, and T has the coordinates 2, 4 on the horizontal line, given by the equation y is equal to 4. And I want to determine the distance between S and T. And how did we arrive at the answer? Well, in this case, here's S and that's T. If you start from S and then just count 1, 2, 3, 4, 5, you'll see the distance between S and T is 5 units. And we just did that by counting those units. Okay. So if P has the ordered pair K, y sub 1, and Q has the coordinates K, y sub 2, lie on a vertical line, x equals K, then the distance between P and Q is the positive difference between the y coordinates. That is, PQ would be the absolute value of y2 minus y1. Okay. The vertical line, of course, that means the x coordinate will be the same for both P and Q. And then if S has the coordinates x1, h, and T has the ordered pair x2, h, and they lie on the horizontal line, y is equal to h, then the distance between S and T is going to be the positive difference between the x coordinates. That is, ST will be the absolute value of x2 minus x1. Okay? And that's because on the horizontal line, your y coordinate is going to remain the same. So all you do there is just take the difference of the two x coordinates and take the absolute value. And here the absolute value sign ensures that the distance is non-negative. Okay? Absolute value is always positive. It's never going to be negative. And distance will never be negative. Okay. Now for this one, the distance formula is an equation for expressing the length of the line segment that joins points A, which is x1, y1, and B, x2, y2, as shown in this figure. Okay. So here, this is an oblique line segment, and I want that distance. So here, it's not obvious here. So here's how we can derive our distance formula for that situation. All right, the point C is the intersection of the horizontal line through A and the vertical line through B. So here's point C right here. That's the intersection of the horizontal line through A and the vertical line through B. So here we're forming what they call a right triangle. And from here we use the Pythagorean Theorem for a right triangle to find, in this case, the longest side. That's the hypotenuse. Okay, so here we see that C has the coordinates x2, y1. So that means that triangle ACB is a right triangle, and the distance AB between A and B is the length of that hypotenuse, which is the longest side. So here, this is where we use the Pythagorean Theorem, which is, of course, C squared is equal to A squared plus B squared. And AB is the hypotenuse. So here, that's going to be AB, and that's going to be squared, is equal to the square of one of the legs, AC, plus the square of the other leg, CB. Now, in this case here, the length AC is this, x2 minus x1. And that'll be the absolute value of that, and then we're going to square it. And also, y2 minus y1, we take the absolute value of that, and we square that as well. Okay, so this is what we'll be left with. AB, and that squared, is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And if you take the square root on both sides, the square root of AB, and you square it, would just be AB. And then that's going to be equal to the square root of all of this. The square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So this is the distance formula derived from the Pythagorean Theorem. The distance AB between points A, which is x1, y1, and B, x2, y2, is, in the coordinate plane, is this. AB is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so that's how we find the distance between 2 points in a coordinate plane. All right, now let's take a look at this example here. Triangle LRN has the vertices, which is L has the ordered pair 1, negative 6, R has the coordinates 5, 2, and N has the ordered pair negative 3, 4. Identify the angle of triangle LRN with this, with the largest measure and the smallest measure. So that's parts A and B of this example. So to get that, here the angle of triangle LRN with the largest measure is opposite the longest side. And the angle of triangle LRN with the smallest measure is going to be opposite the shortest side. Okay. So here we're going to calculate the lengths of the sides here using the distance formula. So here they use LR, and that's equal to the square root of, using the distance formula. X2 minus x1. Now here, x2 minus x1 is 5 minus 1 quantity, or 1 minus 5 quantity squared, either way. and then plus y2 minus y1. Now here they did negative 6 minus 2, and that's squared. Okay, now when they simplified this, and they left out some steps here and how they got their answer, 1 minus 5 is negative 4, and that's squared, plus negative 6 minus 2 is a negative 8, and that's squared. If you square negative 4, you're going to get positive 16, and if you square negative 8, you'll get 64. So 64 plus 16 would be 80, and then take the square root of 80, you'll get approximately 8.9 units using the calculator. And then Rn, now in this case, R is the ordered pair 5, 2, and N is negative 3, 4. So here they did negative 5 minus a negative 3, and that's squared. And then 2 minus 4, here's 2 minus 4, and that's squared. Let's see, 5 minus a negative 3 is actually 8, and if you square the 8, you'll get 64. 2 minus negative 4 would be 2 minus 4 would be negative 2. Square the negative 2, you'll get 4. 64 plus 8 will be 68, and then take the square root of 68, you'll get 8.2 units, approximately. And then, on this next slide, they did L, the distance from L to N. Here it is. In that case, here's L, and that's N. 1 minus a negative 3, and that's squared. And then y2 minus y1, negative 6 minus 4, and that's squared. So in this case, 1 minus a negative 3 will be 4. 4 squared will be 16. Negative 6 minus 4 will be 10. Negative 10. Negative 10 squared will be 100. So 16 plus 100 would be 116. And then the square root of 116 will be approximately 10.8 units. Okay. Now we have to look at which one has the longest side. Okay. 10.8 units, that's the longest side. So the angle opposite that will have to be angle R. Okay, so if I draw a triangle like this, let's see if I can do this. That would have to be L, and I hope this is right. If LN is the longest side, then angle R would have to be the largest angle. And the smallest was 8.2. That was RN. That means angle L would have to be the smallest angle. Okay. All right, let's look at this example. Triangle LRN has the vertices L, which will be 2, negative 7. R has the coordinates 1, 3, and N has the coordinates negative 5, 8. Use the distance formula to help you classify the triangle as acute, right, or obtuse. Okay, so in this case here, we've learned how to use the lengths of the sides of a triangle to classify the triangle as acute, right, or obtuse. So here they're letting C be the length of the longest side, and A and B be the lengths of the other two sides. Okay. Now there is some type of rule here that says this. If C squared is less than A squared plus B squared, then triangle LRN is an acute triangle. If C squared is equal to A squared plus B squared, then triangle LRN will be a right angle. Or if C squared is greater than A squared plus B squared, then LRN, triangle LRN, is an obtuse triangle. And here, they use the Pythagorean Theorem to come up with a distance from O to R, which is the square root of 10, R to N, that's the square root of 61, and Ln, O to N, that distance will be 270, the square root of 274. Now, in this case here, we're letting C equal to the square root of 274, and A be the square root of 101, and B be the square root of 61. That would mean C squared would have to be 274, and A squared plus B squared is equal to 101 plus 61, which is 162. Okay. Now, as you can see here, C squared is greater than the sum of A squared and B squared. That's 162. That means that triangle LRN will have to be an obtuse triangle. Okay. All right, now let's take a look at problem number 1 on page 794. I apologize for the blurriness of, this is not clear, but this right here is point A, this is point B, and that's point C. And you're told that ABCD is a parallelogram, and you want to find the coordinates of each vertex, A, B, C, and D. Well, I know what A, B, and C are. If you look at A right here, the coordinates for that would be to the left 3 and down 1. So that's -3, -1. And here's B up here. It has the coordinates, in this case, -5. You go to the left 5, that's -5, and up 1, 2, 3, 4. So B has the coordinates -5, 4. And then point C is over here. That would mean, if we start at the origin, that's going to be to the right 3 and up 1, 2, 3, 4. So we need to know what D is going to be. Okay, there is a property that deals with parallelograms that the opposite sides are equal in measure. So, without using that distance formula, I can find the distance from B to C because of the fact that B and C have the same y coordinate of 4. So if I count from B to C, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. From B to C, that distance is 8. That means from A to D, that distance has to be 8 places, or 8 units. So here, I'm going to start where A is and count over 1, 2, 3, 4, 5, 6, 7, 8. Here's where D is. And the ordered pair for D will have to be, in this case, 5, -1. And notice if you look at A and D, the y coordinate for A and D are the same. So that point makes up parallelogram ABCD. Okay. All right, take a look at this example. Problem number 4 on page 795. Triangle ABC is a right triangle, and we want to find the coordinates of C. Well, that's easy because we can just read off of that and just, here's point C, we can get the ordered pair just from there. So to get to C, we have to start at the origin and go to the right 4 and up 1, 2, 3, 4, 5. So the ordered pair for C will have to be 4, 5. Okay. All right, let's take a look at problem number 11 on page 796. Here you're going to find the area of the quadrilateral with the vertices A, which is negative 2, 2. B has the coordinates 3, 5. C has the coordinates 10, 5. And D has the coordinates 5, 2. Okay, so in this case here, let's plot this on the coordinate plane. And I'm going to use my own graph paper that I have here. Okay, let's see. A has the coordinates negative 2, 2. So in this case here, I'm going to go to the left 2 and up 2 and draw the point and label that as A. And then B is the ordered pair, has the coordinates 3, 5. So to the right 3 and up 1, 2, 3, 4, 5. And I'll label that as B. And C is 10, 5. So in this case here, to the right 10 and up 1, 2, 3, 4, 5. And I'm going to label that as C. And then finally D has the ordered pair 5, 2. So this will be to the right 5 and up 1, 2. That would be D. And if you connect those 4 dots, you'll see that it is a parallelogram. So that's what that parallelogram looks like. Now they want the area of that quadrilateral, and it is a parallelogram. So here, there is a formula for the area of the parallelogram, the base multiplied by the height. So in this case, this going to cost is the base. The height is usually going to be this length right here. So by looking at this, I can find out what the base is by looking at the distance from A to D. They both have the same y coordinates. So from A to D, I can count over 1, 2, 3, 4, 5, 6, 7. The distance from A to D is 7. That's your base. The height is this. Goes straight up and down, and it is perpendicular to the base. So that height, if I go from B up to down to this point, start here, and I'm going to go down 1, 2, 3. That's your height. The height there is 3 inches, well, 3 units. And now I can use the formula for the area of the parallelogram. A is equal to B times H. So substitute. This will be 7 times 3, which will give you 21. So the area of that particular parallelogram would just be 21 square units. We'll just say that. 21 square units. So it does help to plot those ordered pairs on the coordinate plane and connect those points to form that parallelogram so you can see what this is. And here I didn't have to use the distance formula in this case, or in the other example as well. Okay, take a look at problem number 22 on page 796. It says here, P has the ordered pair of 0.5 and 9.25. Q has the ordered pair 3.5 and 8.75, and R has the ordered pair 2.25 and 7.5. Those are the vertices of the right triangle. Which line segment is the hypotenuse, and explain your answer. And yet, let me use another one of these graph coordinate grids here. So here we got 0.5 and 9.25. 0.5 is halfway between 0 and 1, so I'm going to go halfway there. And up 1, 2, 3, 4. Here's 9 and about a fourth of the way. That's going to be about right here. And that was point P. Q, 3.5 and 8.75. 3 and halfway between 3 and 4. 8.75. Here's 8 and about 3/4 of the way. Here I'm kind of estimating here. So this is Q. R, 2.25 and 7.5. So this is 2 and about 1/4 of the way, and then 7 and 3/4 of the way will be about right here. And then I'm going to connect those 3 dots, because it does say that it forms a right angle. I mean a right triangle. That would mean the right angle will have to be at the vertex. And that's point R, by the way. So that's what that right triangle looks like. Now, which line segment is the hypotenuse, and explain your answer? Well, again, we don't need to use the distance formula because of the fact, or we should know, that the right triangle is right here. The longest side is always going to be opposite the largest angle. And that 90-degree angle is the largest angle. So angle R is the largest angle. That means the side opposite that will have to be line segment PQ. So here, line segment PQ is the longest side, or the hypotenuse. Okay. There's some properties that you probably need to know that are dealing with geometry that were in other sections in chapter 11. Okay. So here, the largest angle is always opposite the longest side. And then the longest side is always opposite the largest angle. So PQ is the hypotenuse. Okay. Take a look at problem number 40 on page 797. Now this one, we're going to have to use the distance formula. And it's going to be used in a different way because you're told the distance between the ordered pair x, 3 and the ordered pair 2, 7 is 5. And you want to find out what x is. So here, this is where we're going to have to use the distance formula, where d is equal to the square root of x2 minus x1, quantity square, plus y2 minus y1, quantity square. Now, and by the way, let me write this out, because I already know what the distance is. It's given to be 5. So here, that d is going to be 5, and that's going to be equal to the square root of, this will be x2, this will be x1, x minus 2, quantity square. And then plus, this will be y2 minus y1, 3 minus 7, quantity square. Now let's see if we can simplify this. Well, before I do that, let's do this. Let's get rid of that radical, that square root. The opposite of taking the square root would be to take the square on both sides of this equation. So when you square both sides, you're going to eliminate the radical. So 5 squared would be 25, and that's equal to, this radical will be gone after squaring it, so you'll have x minus 2 quantity squared plus, plus, it should be plus. If I do 3 minus 7, that's going to be negative 4, and that's going to be squared. Now if I square the negative 4, that's going to be 16. So this will be 25 is equal to x minus 2 quantity squared plus 16. And now I'm going to get x minus 2 quantity squared by itself. I'm adding 16, so I need to subtract 16 on both sides. That means 25 minus 16 will be 9, and that's equal to x minus 2 quantity squared. And now next I need to get rid of that square for the x minus 2. X minus 2 is being squared, so the opposite of that would be to take the square root on both sides. Now I think if you take the square root on both sides, I need to include something else. That plus or minus symbol. So here the square root of 9 would be plus or minus 3, and that's equal to just simply x minus 2. Now, because of the plus or minus, I do have two possibilities where x minus 2 is equal to 3, or x minus 2 is equal to negative 3. And then we solve this equation, each equation for x. So for the x minus 2 is equal to 3, if I add 2, you're going to get x is equal to 5. And then for the x minus 2 is equal to negative 3, if I add 2, you'll get x is equal to negative 1. So here we got two possibilities for the x. X could be 5 or x could be equal to negative 1. Okay. There's a rule in algebra where if you take the square root on both sides of an equation, you have to include the plus or minus symbol. Okay. All right. There is going to be a part 2 to this particular video on section 13.2, so be on the lookout for that as well. Okay.